in your previous class, we have to deal about law of inertia, and we have give some examples of law of inertia as inertia of rest. And now we have to take an example of inertia of motion. So what are the examples of inertia of motion? Now take the previous example as in this case the car is initially at moving with a constant velocity and a body is at that car. Now the car is moving, that's why the whole body part associated with the car is also moving with that same speed. That is, in the case of in this case the whole body will move at a constant speed. Now certain brake is applied on that car. Due to that car, the application of that brake, the lower part of the body will retain its position of inertia of motion. That means the lower part of the body will tends to move at that particular position, but the upper part of the body, which is not associated with the platform of the car, will remain at rest. So due to that the body is moved in a forward direction, the lower part will move forward direction, but the upper part of the body will tends to regain its original position. So this is the case of inertia of motion. Now, so there are some practical examples which govern the laws of motion. First law of motion, which is laws of inertia. Now for that laws of inertia, in every examples there are external applied, some kind of applied force, which is applied physical quantity, which is actually named as force. In case of second example, we have to apply a brake to stop the car. That brake is act as the amount of force. So let's conclude the definition of force in a qualitative way as follows. Force is an external physical quantity which is applied to a body to change the position of the body or intended to change its position of the body. That means if we apply force, the body always changes position. It is not true. Body either change its position or it is at its original position. Why? Because the applied force, if the applied force is more enough, that the force is actually overcome the body's inertia, in that case the force will apply to change the body's position. But irrespective of that condition, force is an external physical quantity which is applied on that body to change the body's position. Now this is the outcomes of the Newton's first law, but we can't measure the force. So for the measurement of the force, we have to require the quantitative definition of force. Now the Newton's second law is arrived. If we apply a force on a particular body, this is directly proportional to the mass of the body. If the body's mass is huge, then the applied force is also huge. That means the force is also applied greater amount to change its position, and F is also directly proportional to the acceleration produced in the body, which is the rate of change of velocity. That means F proportional to m into a. That is, this is from the constant of proportionality or proportionality relation, F equal to F proportional to m into a. Now F equal to kma, where k is the force constant or a constant of that equation. Now from the experimental observation, it is found that k equal to 1. So the final result should be F equal to ma. And that equation derived due to the case of F directly proportional to m and F directly proportional to a, and these two quantities, this equation have to be derived if the measurement is possible. So measurement of that force is the measurement of the mass and measurement of the acceleration. So F equal to m into a. Now in your previous class, that a is nothing but v minus u by t. That means this is the final velocity and this is the initial velocity and this is the time. So F is nothing but m v minus u by t. That means mv, a new quantity is arrived, mv or mu. That mv, that means mass times the velocity, that gives you another physical quantity which is called the momentum of the body. Now Newton's law is only true whenever the body moving in a straight line. So as the body's movement is through the straight line, that's why this kind of momentum is called linear momentum. But if body moves in a circular path or a trajectory which is not straight line, then there is also a momentum which is called angular momentum. Now Newton's actually derived this law for the linear momentum. Now there is a change in momentum. This is the final momentum, this is the initial momentum, and this is the change in momentum. So change in momentum is directly proportional to the applied force, and whenever the direction of the force applied, the momentum change should be in that direction. Otherwise, if we say it that the change in momentum is directly proportional to the force applied and the direction of the change in momentum is the direction of the applied force, then this law is called Newton's second law of motion. And from that Newton's second law, we have to apply this, and the equation which is the rate of change of momentum with respect to time, that gives you the measurement of force. So this is the measurement or the outcome of the Newton's second law. Now from the Newton's second law, we can actually calculate the unit of force. Now the unit of mass is kg, and unit of velocity is nothing but meter per second, and this is also time which is by second. So it is kg meter per second square, or it is called Newton. So this is the SI unit of force which is called Newton. Similarly, the CGS unit of force is dyne. What is that? F equal to gram into semi per second by second. That means gram semi per second square, which is also called dyne. Now there are two units measurement. One is for SI, another is for CGS. So this is the SI unit of force, and this is the CGS unit of force. Now there is also a unit which is called gravitational unit of force, which is called kgf and gf. Kgf is the gravitational SI unit and gf is the gravitational CGS unit. Kgf means or defined as if we applied a certain kind of force which produce an acceleration, which is the acceleration due to gravity of a body of mass 1 kg, then it is called 1 kgf. And if acceleration is produced, acceleration due to gravity, the same of acceleration due to gravity in a body of mass 1 gram, then the applied force should be said as 1 gf. The relationship between 1 kgf and Newton is like that.